Greetings, teammates. Hello to the super second hour and the fighting fifth hour. You'll be watching this on the 25th of March. It's another special problem, and I want to do one more. You're gonna watch. Hopefully, you watched the video before this. If not, stop and go back and watch the flipping physics video. It's gonna take you through a problem very similar. On that problem, Mr. P, he's got kind of a tortuous derivation. That's okay. Try to follow that. Hopefully you try to follow that. I'm going to show you a simpler way, but never lock yourself into only one way of solving any problem. The more ways you can bring to bear, the stronger you're going to be. Not just in physics, but I think in life in general. If all you got is a hammer, everything looks like a nail. So we're going to help build some more skills. So we're going to look at a car going over a hill. Now we've done that before. A special case though, what's the max velocity that car can go over the hill and still stay on the road? And you saw from the video, it's essentially going to be a free fall situation. If the only force acting on the car, so if the car leaves the road, there's no more normal force. And we're only looking at vertical forces for these. So the only force the car would feel is the force gravity down. And that is our condition for free fall. The only force acting on the car or on the object is gravity. So we're gonna look at that. I'm going to give you a mass, but we're really going to find we don't really need the mass. And you saw in the video, I'm going to ask you to pause. And again, your task, what's the car's max velocity? The radius of that hill is 20 meters. The mass of the car is 1,200 kilograms. Pause the video. Take a shot at solving it. Spend no more than 8 minutes. And rejoin me when you've gave it a good effort. So I'm going to assume that you've given it the fighting chance. Let me fix this right now because I went and found a ruler. I got this right when I first started teaching. Of course, everything I own is pretty much at the school, but that makes me feel better. That's our radius. So let's look at this situation. So the cars, we want to see what the max velocity is. So we know our in force is going to be our force centripetal. I'm sorry, it's our net force is going to be down. And as the car goes faster and faster, if you could do multiple iterations of this, you run the car again and again and again, you would see this normal force as the car's velocity increases. You would see this normal force get smaller and smaller and smaller with each iteration until eventually the car is no longer on the road. And that's what we want to look at in this case. So for that to happen, the only force we have at all is force gravity. And so we know that in that case, so force centripetal equals our net force. That's the only force we have. We know that in that case, mg equals our centripetal force. Our weight equals our centripetal force. And we know it's that. It's the only force acting. So force centripetal is mg, no normal force involved. And here's what you can do, and here's what Mr. P was taking you through on the video. You could put the mass in, you sure can, but you don't need to. Because right here we can cancel the masses. We don't need no stinking masses. And now we have little g equals v squared, velocity squared over r. And we're using velocity that instantaneous velocity when the car is right there at the top of the hill. We could call it speed. We're going to call it instantaneous velocity just to be consistent. And we're going to solve for velocity. And again, you can plug in the numbers, but I'd ask you, don't be a number dependency victim. You're going to find that the more you can avoid putting those numbers in, the more options are going to open to you. And just in this case, I'll show you here. We're going to multiply both sides by r. So we get g times r equals v squared, because your r's are going to cancel. We want velocity, not velocity squared. So we're going to take the square root of g over r is going to give us velocity. And now we want now that'd be the relationship right there. But let's solve it. We're going to use 10 meters second for g. We have 20 meters for our radius equals our velocity. 10 times 20 is 200. So square root of 200 meters second times meters is meters squared second squared. I was smart enough to take one of our calculators though. Square root of 200 gives us 14.14 meters per second is our velocity. So if our car is going at 14.14 meters per second, that's all of that. The only force acting is gravity. There's no normal force. So at that velocity, our car will be in free fall and no longer be in contact with the road. It's good. All right, teammates. Have a great day, and I'll check in with you tomorrow.